Hi guys, and today on Engineering Science Geometry. In engineering, geometry involves the analysis and study of relationships among shapes and has numerous practical uses. For example, the concept of perimeter is used to compute the amount of material needed for a specific job. And the learning outcomes for today's session would be: use given formula to calculate areas and perimeters of plane figures. And use given formula to calculate lengths, surface area, and volume of common solids. But first, we need to understand what are quadrilaterals. In geometry, a quadrilateral can be defined as a closed two-dimensional shape which has four straight sides. We can find the shapes of quadrilaterals in various things around us, like in a chessboard or a deck of cards, a kite, or a simple form of an arrow. All of these would comprise a quadrilateral. Properties of a quadrilateral. In quadrilaterals, there are polygons, and a polygon is a closed plane figure bounded by straight lines. Examples of polygons would be: for three-sided figures, they are called triangles. Four-sided figures are called quadrilaterals. Five-sided, pentagon. Six-sided, hexagon. Seven-sided, heptagon. And eight-sided figures are octagons. Types of quadrilaterals. There are 5 types of quadrilaterals, these being rectangle, square, parallelogram, rhombus, and trapezium, all of which have 4 sides. For quadrilaterals, which are 4-sided figures, if the opposite corners of any quadrilateral are joined by a straight line, 2 triangles are produced. Since the sum of the triangles, or the sum of the angles of a triangle, is 180 degrees, the sum of the angles of a quadrilateral are 360 degrees. And here we have the basic shapes for each type of quadrilateral. We have rectangle, rhombus, square, trapezium, and parallelogram. Areas of plane figures. So for each quadrilateral, we need to know what is the formula to find the area or surface area. And for a square, the area is x squared, or side by side, or side squared. For a rectangle, area is length by breadth. For a parallelogram, area is base by height. A triangle, the area is found by half base by height, multiplication understood in between each quantity. A trapezium, area is found by half a plus b multiplied by height, AB being 2 sides. For example, a rectangular tray is 820 millimeters long and 400 millimeters wide. Find its area in A, millimeters squared, B, centimeters squared, or C, millimeters squared. So first, we need to identify the formula that we will need to calculate the area. Since it is a rectangle, then length by width would be the formula used. So therefore, we have 820 being the length and 400, which is the width, multiplied would give us 328,000 millimeters squared. Part B of the question asks that we convert millimeters into centimeters. So 1 centimeter squared is equal to 100 millimeters squared. Hence, 328,000 millimeters squared is equal to 328,000 divided by 100. And this will represent 3,280 centimeters squared. So we converted from one subunit, which was in millimeters squared, into centimeters squared. Part C, the answer is supposed to be represented in meters squared. And 1 meter squared is equal to 10,000 centimeters squared. So we are converting from centimeters squared into meters squared. Hence, 3,280 centimeters is equal to 3,280 divided by 10,000, and our answer will be represented in meters, which is 0.328 meters squared. In the second example, we have this plane shape here, and the question is, For the figure above, determine the cross-sectional area. So the cross-sectional area would be the entire surface area of this figure. So here we have to picture in our minds what is the easiest way that we can represent this figure. And the easiest thing to do would be to divide that shape into a common recognizable shape. In this case here we would get three rectangles, A, B, and C respectively. So we would have to basically find the area for each rectangle and add them together. So for the area of a rectangle A, that will be 50 by 5 is equal to 250 centimeters. For rectangle B, there's a piece of working here that we will have to look at in terms of the height. The height given in the diagram there represents the total height of the shape. But there are portions which will be the 8 millimeters and 5 millimeters that would be taken off to compensate for the height of rectangle B. So we will end up with 75 subtract 8 subtract 5 multiplied by 6. So that will leave us with 62 by 6 is equal to 372 millimeters squared. The area of rectangle C is 70 by 8, and that will give us 560 millimeters squared. Therefore, the total cross-sectional area is equal to 250 added to 372 added to 560 is equal to 1182 millimeters squared. Or we would have to basically Therefore, the cross-sectional area is equivalent to the sum of all the rectangles added up. So 250 plus 372 plus 560 would give us 1182 millimeters squared. Now we can re-represent this in the form of a subunit. So the answer would be 1128 centimeters squared. Now we can re-represent this into a subunit. So therefore the answer would be broken down further into 11.28 centimeters squared. In example 3 here, we have a basic shape here, and we have to determine the area of the concrete pathway. So first step is to identify the formulas needed to calculate this. And to identify the formulas, we would need to know what shapes are we dealing with. So we have two shapes involved here. We have an inner shape, which is a rectangle, and an outer shape, which is another rectangle. So basically the area of the concrete pathway will be the area of the large rectangle subtracted the area of the smaller rectangle. So this would result in the formula being area is equal to length by breadth subtract length by breadth, which will give us 25 by 20 subtracted 21 by 16. The answer would be further broken down into 500 subtract 336, which will result in 164 millimeters squared. Now on to the circle. For a circle, we will need to identify the main parts of a circle. First one being the circumference or the perimeter of a circle. Second, the diameter, which is a line cutting through the center of a circle. The radius from the center of a circle to the outer end, and a tangent, which is basically a straight line touching the outside of a circle. Other properties of a circle that we will need to remember would be sector, segment, quadrant, chord, and arc. And each part here is represented diagrammatically. Area applied to circles. For a circle, the area is found by pi r squared or pi diameter squared divided by 4. For a semicircle, the area is found by area is equal to a half pi r squared or pi diameter squared divided by 8. For a sector, the area is given by the angle divided by 360 degrees. Then that is further multiplied by pi r squared. Now on to some examples. Problem 1 here. Find the circumference of a circle of radius 12 centimeters. circumference of a circle is equal to 2 pi radius or 2 pi r, which would result in 2 pi multiplied by 12, which will give us 75.40 centimeters. In problem 2 here, if the diameter of a circle is 75 millimeters, find its circumference. So in this case here, we are given diameter. So utilizing the diameter of a circle, the circumference is found by pi multiplied by diameter, or pi d, which is equal to pi by 75, which is equivalent to 235.6 millimeters. So the quantity for pi that we usually use is 3.142, or 22/7. Or we can just utilize the pi function on our calculators. In our third example here, determine the radius of a circle if its perimeter is 112 centimeters. Perimeter is equal to the circumference. Therefore, circumference is equal to 2 pi r. So we have to transpose 4r in this case. Hence, the radius r is equal to c, which is the circumference or the perimeter, divided by 2 pi, which gives us 112 divided by 2 pi. The result is 17.83 centimeters. Another example here, a hollow shaft has an outside diameter of 5.45 centimeters and the inside diameter is 2.25 centimeters. Calculate the cross-sectional area of the shaft. So we take a look at the shaft and we can break it down into two simple shapes: an inner circle of diameter 2.25 centimeters and an outer circle which is 5.45 centimeters. So essentially what we are doing, we are finding the area or the cross-sectional area of the shaded section. Area of the shaded part is equal to area of the large circle subtracted area of the small circle. And the area is given by the formula pi d squared, again d representing the diameter, divided by 4. Since we have the same formula to find the area of each circle, then we can further break it down into something more simplified. So therefore, pi divided by 4 multiplied by d squared of the large circle minus d squared of the smaller circle. This will result in pi divided by 4 in brackets, which means multiply by 5.45 squared minus 2.25 squared. The result would be 19.35 centimeters squared. In this further example here, we have a plane figure that is in the form of a rectangle, but there is a shaded section, and we need to calculate the area of the shaded section. So we have two basic shapes that we can identify. We have the outer area, which is the rectangle, and then we have an unshaded area which looks like a sector. So we need to identify first what are the formulas that we would use to find the area of the rectangle and the formula that we would use to find the area of a sector. For the area of the rectangle, we would need length multiplied by breadth. For the area of the sector would be the angle divided by 360 multiplied by pi r squared. And in the case of the rectangle, the angle that we're looking at would be represented by 90 degrees. So the actual figures inputted into the formula would be 120 by 90, which is the length by breadth for the rectangle, subtracted from 90 divided by 360 multiplied by pi multiplied by 80 squared. So that there would represent the equation for calculating the total area of this shape. So therefore the area is equivalent to 10,800 minus 5,027, which will give us 5,737 millimeters squared. As we move from circles into solids, we have the volume for common solids. And our first solid would be a prism. And to calculate the volume of a prism, it would be length multiplied by breadth multiplied by height. Then we have the surface area of the prism is equal to 2 breadth by height plus height by length plus length by breadth. in brackets there. So that identifies that we have to work out whatever quantities we have in brackets first before we apply whatever is outside of the brackets. Then we have the cylinder. A cylinder, the volume is calculated by pi r squared multiplied by height. The total surface area is given by 2 pi radius by height plus 2 pi radius squared. Then we have a pyramid. The volume of a pyramid is a third by area by height, where A represents the area of the base and H represents the perpendicular height. Total surface area is the sum of the areas of the triangles formed. So we need, in order to find the total surface area of a pyramid is given by the sum of the areas of triangles forming the sides plus the area of the base. For a cone, the volume is given by a third pi r multiplied by the height. The curved surface area is given by pi r L, L representing the length. Total surface area pi r L plus pi r squared. For a sphere, the volume is given by 4 over 3 multiplied by pi r cubed. The surface area is pi r squared. For a sphere, the volume is given by 4 divided by 3 multiplied by pi r cubed. The surface area is 4 pi r squared. For example, a water tank is the shape of a rectangular prism having length 2 meters, breadth 75 centimeters, and height 50 centimeters. Determine the capacity of the tank in A, meters cubed, B, centimeters cubed, and C, liters. Volume of a rectangular prism is equal to length by breadth by height. Therefore, the volume of the tank is equal to 2 multiplied by 0.75 multiplied by 0.5. This would result in 0.75 meters cubed. Part B of the question asks that we represent the value in millimeters cubed to centimeters cubed. So 1 meter cubed is equal to 10 to the power of 6 centimeters cubed. Therefore, 0.75 meters cubed multiplied by 10 to the power of 6 centimeters cubed is given by will give 750,000 centimeters cubed. Part C asks that we express the given answer in liters, and 1 liter is equivalent to 1,000 centimeters cubed. Hence, 750,000 centimeters cubed is equivalent to 750,000 divided by 1,000 liters, would be 750 liters. In our final example here, we have to find the volume and total surface area of a cylinder of length 15 centimeters and diameter 8 centimeters squared. The volume of a cylinder is given by pi by radius squared by height. Since diameter is equivalent to 8 centimeters, then the radius is equivalent to 4 centimeters squared. Hence, the volume is equivalent to pi by 4 squared by 15 will give us 754 centimeters cubed. The second part of this question asks that we calculate the total surface area. And for this part, I would ask you to take out your calculators and find the surface area. So the solution to the problem would have been 2 pi radius multiplied by height plus 2 pi radius squared. This would result in, and in brackets, 2 by pi by 4 by 15 plus 2 by pi by 4 squared. This will result in 477.5 centimeters squared. So I hope that you guys got that answer correct. In conclusion, we calculated the areas of plane figures. We calculated the areas of circles and the different parts of a circle in terms of semicircle and a sector. We also found the volume of solids. An example of solids would be a prism or a pyramid. So be sure to remember your respective formulas and I will catch you guys in our live interactive session. Until then, be safe.